Alright, welcome back. Beautiful flowers there in the corner for you. You can totally tell they were my idea. Now, moving forward, you can write and solve the equation. So the only thing we do now is we switch that equal sign to an inequality. And I'll explain to you what I mean by that. So first, to review a little bit, we got the number line. Okay? So I see that this is a decimal, and this is a decimal. So what I would probably do is type 1 divided by 4 in my calculator to get 0.25. Then I would make that a decimal. Okay? I can tell from this that I need to go from negative, z here is negative, so I probably would have made this negative 0.1. That means this could have been 0, this could be 0.1, 0.2, 0.3, 0.4, 0.5. That's probably how I would have did my scale. Then I look at that, 0.05 is going to be halfway here. Okay? If you don't know how I got z to be between negative 0.1 and 0, come see me and we need to talk. Alright, then a quarter is 0.25, so just like that, it'd be here, x, and then y would be almost 4 here, somewhere in here. So make sure you have you can put numbers on a number line, because having that number sense is going to help us solve all these equations. So then another one here. Alright, so I see a decimal. It's easier to go from a fraction. So most of you should know that's 2.5. And C is going to be 2.6 repeating, or 6.7. I would have probably said 6.7, because I'm looking here, this is 6.75. So I actually need to know that C is less than A if we don't round into the very end. So what I would do, for my scale, I only need to go from 2.5 to 2.7. Right? So I might go 2.5, 2.5, I don't know, 2.525, 2.55, 2.757, I don't know what I'm doing. Stop. 2.5, I'm making mistakes. I don't know, make this 2.6. Make this 2.7. So then within that, I would say this is 2.65. Making that, I would see this C. C would need to go about right here. I'd put C there, and I would know A is just a little bit bigger. And then B is obviously down here at 2.5. So just understanding which numbers are bigger is going to be half the battle. Alright, another one. Why is this one on here? Because we want you to look at negatives. Alright, if you type 2 divided by 1, or 2 divided by 5, you're going to have negative 1.4, and then this is going to be negative 1.3 remaining. So I go from 0.3 to 0.4. So I would have probably did negative 1.4 here. So then I could do negative 1.39. This one would be negative 1.37 if I skipped one, negative 1.35, negative 1.33, negative 1.31, negative 1.30. Alright, so 33 repeating would have been just right here, probably just on the other side of it. That would have been x. Negative 1.4 would have been y. And z is right here. I didn't put that label on there, so that's going to be negative 1.38. Notice how the number line goes the other way now, because your bigger numbers are farther away. Sweet. 4. This one's pretty cool. If you write 16 divided by 5, you're going to get 3 times, but then you're going to have 1/5, so it's 3.2. This is going to be 3.25. We talked about that. 3 2/9, I believe, is 3.2 repeating. And look at that. I could probably put 3.20 here, 3.21. This one could be 3.23. This one could be 3.25. That shows y here, right? That shows x here, and 3.2 or 3.2 repeating would be here, probably somewhere just on the other side of that for z. So just make sure you're looking at what you need to do. Alright, so remember these 4 steps. Simplify each side by combining equal sign by distributing combining like terms. So those are the same 4 steps as last time. Gather the variable to the equal signs, addition and subtraction, multiply, division, coefficient. I know you can do that stuff. You did the practice for 1. And if you copied the practice for 1, this is an example of where it hurts. Because we're doing the same exact thing. Okay, so looking at this one, I would see this part right here, I would distribute both of them. So I would look at this as 8a. Now a negative times a negative is going to be a plus 20a. And a negative 4 times a negative 2 is going to be a plus 8. Remember, questions, questions, questions. Alright, 8 and 20 is going to actually be 28a, alright, plus 8 equals 12a. Here I would probably subtract 8. Okay, and then I would subtract 8 on this side. That would leave me with 28a equal to 12a minus 8. I would subtract the 12a. That goes to 0. Subtract 12a. This is actually 16a is equal to, see this right here in green. That whole negative has to come down to one of the most forgetful things in algebra. Divide by 16, and finally we have a equals negative a half. Okay, that's the most common one. I know I can reduce 8 by 8 and 16 by 2, so I would have just did it that way. Alright, looking at 6. Ooh, this is another one of my favorites. Alright, on the last one I showed you this. I'm dividing by 3 here, so I'm actually going to multiply everything by 3. 3 times 2 is 6, so if I did 3 times 2, that's 6, but divided by 3, I'm back at 2x, and that's why I do that. But then 3 times 4 is 12x, and 3 times a negative 20 is a negative 60. So then what I have here is 14x, because this is just combined terms, equals negative 60. Divide by 14, divide by 14, x equals, and if you're thinking about rounding, you're 110% correct. Alright, looking at that, if you look at your calculator, you do 60 divided by 14, okay, you're going to get a negative number. So the first thing I would do is write a negative, probably a 4, and then I look at this, let me write it down. It'd be 4, 2, 8, 5. So 5 is big enough number to make this 8 a 9. So I would rewrite it here, negative 4.29. So I told you on the last notes video we want to have decimals. Okay, so moving forward now, let's look at these. Alright, fill this chart in. Symbol, less than. Symbol, greater than. Alright, look at some of the other words that means. These are your language you got to look for. And the red is the language you look for in your word problems. Alright, sometimes they might just actually say less than, greater than. But we want to know, and you got keywords to figure out. Less than or equal to, greater than or equal to. Remember, alright, so this is one helpful hint here. You always flip the sign when you multiply or divide by a negative number. So let's see what this looks like. So right now, I would look at this. I would say negative 4 times 5 is negative 20w. Negative 4 times the negative 8 is going to be a positive 32. It's greater than 52. If I subtract 32, you're going to have negative 20w is greater than 20. Notice this sign is still the same. Green doesn't show up. Okay, notice this sign I brought down. So this sign is just an equal sign here. Until this point, when I divide by negative, I have to do what? Flip the sign. So I'm going to make it this way. This is what they mean by flip the sign. Okay? So this is where we flip the sign. Because of negative division. So negative is the key word there. Now 20 divided by negative and all that stuff, you get a negative. Alright, so that's a 1W. Negative 20 divided by negative 20 is still just a positive 1. So that's why I have a 1W. Now to graph this, what I usually do is I put 0 on here. Terrible spot for 0. I probably put 0 here, and I put negative 1 here. Numbers that are less than negative 1. Alright, so if I would do 0 is less than negative 1, this is a false statement. So what I usually do here is I would make a hollow circle at negative 1, and then I would graph the other way that doesn't include 0. Okay, so that's how I would typically graph that. That's how I was taught. Good luck. Number 8. Okay, so here I probably subtract 13 again. Subtract 13. So I'd have negative 4k is less than or equal to 14. That looks like good math. I would divide by negative 4. Divide by negative 4. So we're checking right now to make sure that you know to do what? Flip the sign. I didn't even do it there, so good thing I'm talking you guys through it. So this is about 3. Whoa. This is about 3.5. It's also a negative 3.5. So I did that wrong last year. So I would go to 0. I would find negative 3.5. So to help me know, is 0 greater than negative 3.5? True. So then what I do is I fill in this circle because it includes 3.5 because it says greater than or equal to, and then I shade this way. Okay? And that's the best way to do that. Okay, handful of examples here. This one we can kind of do. How about we try doing 2 at 1? So I'm going to subtract 5 from both sides. That gets rid of that. Then I'll put the x's on the left. See how I did 2? I probably could have did different colors. I know right now both of these cancel out. 9 minus 4 would be 5x. That's an awesome smartboard issue there, but whatever. Alright, is greater than 15 minus 5 is 10. Divide by 5 then. And x is greater than 2. So I would go down here, and I would probably go 0. You can put 1 in there if you want. 2. Greater than 2 is going to be 3 and 4 and 5. So if you want to make yourself feel better and know that 3 is greater than 2, perfect. And you shaded correctly there. This is another one. This is one where you can do that negative 3 trick if you like that. The important thing here is this piece. Okay, what you'd need here would be B, or what you would have here would be B, alright? Then I'd say minus 15. I'd have to flip the sign, and that would be negative 30. Alright, so then negative 30 would be here. Now, looking at this, I would add 15, and B is greater than a negative 15. So, greater than negative 15, you probably want to here, greater than, and 0 is greater than 15, so I could put 0 here. And that's what you're looking for every time you do that. Also, more importantly, are these quiz questions. So these are a couple, 2 I think on your quiz, so this is what we're looking for. Charges 15 for admission and each ride. So 15 for admission, 15 for admission is actually, this is a flat rate. 15 doesn't change. No matter what, it's 15. For each ride, so look for that each ride, because X then needs to be the number of rides. Alright, so then you look at this, we got 250 X plus 15, and now I only have 60 bucks, so I need to be less than or equal to 60 bucks. I don't know how to do this. Alright. I can't see, solid fill, yellow. Done. Uh-oh. No, go back. I got it. There you go. Now, minus 15. Sorry about that. It's easier to read, I hope. So now I'd have 250x. So after I pay that admission fee, how much money would I have left? I'd have $45. And now I'll divide by 250 to see how many rides I can go on. So then x is less than or equal to, what is that, 18? So how many rides can go on? So I can go on as many as 18 rides. I mean, that would be the best answer I could think of. $12. Oh my goodness. Alright, so let's try this again. Alright, you have $18.50 to spend on 50. So that's how much I have. So a lot of people right away will write $18.50. Now, you have to spend less than or equal to that. So 14 bucks. So I know it's $14 right off the bat, plus 75 cents for toppings. So 75 cents for each topping. So that makes X my number of toppings. Alright, then I would subtract that initial price of $14 off. Alright, I get 0.75x is less than or equal to 450. Divide by 0.75, divide by 0.75x is less than or equal to 6. So what does that mean? Or at most, there's a good word, I can order 6 toppings. And I've never been told I'm an English genius, so hopefully that's a complete sentence. Remember, word problems should be solved with words. Okay, I have no idea what I just did. Alright, last one. 17 slides later. Alright, we're going to go to that. Bam. Yellow. Bam. Okay, real quick. 4 Park College basketball games. It costs 15 bucks to pretend. A season pass costs 170 bucks at most. So here's a good one. So this is X is equal number of games. So this one's pretty straightforward. It's 15 bucks for each game. But a season pass costs 170. So they just want to know how many times does it cost to go. So if I did X is less than or equal to, you're just going straight forward. So this is 11.3 repeating. So this is season on that side, and that's per game. So you're comparing the season price versus paying for each game. So Okay, so here's the question though. At most, how many games could you attend? So if I'm only going to 5 games, it'd be cheaper to pay per game. But if I'm going to more than 11, then it'd be cheaper to get a season pass. So at most, I could attend 11 games. Alright. There you go. You got it. Now, that was long. I understand that. Couple goof-ups in there. I didn't like that color. It's hard to see and read and write and all that stuff. Let me know if you have questions. The inequalities and the writing them is where most kids struggle every year, so you can't be afraid to self-advocate for yourself. I'm here for you. I won't let you fall on your face. We'll help you out. You just got to come and ask. And I know it's hard when I'm not looking you in the eye to say that, but get in here and get some help.